Welcome, everybody. Thank you for joining us this afternoon. For those who don't know me, my name is Jessica Finn. I am the Membership Manager at NFRC. And today's webinar, New Buildings Institute Carbon Reduction Solution, is sponsored by Schuco, and we have a brief video to show everyone today.
The research and development for Schuco through its technology center and in-house testing center in Germany is second to none in our industry. We do know that there are differences in the US market compared to the European market. We've taken our experience and we've custom tailored a lot of the products so they fit this market and they can meet the standards and requirements of the US market.
The only logical way forward for us to bring our product effectively into this market is by taking responsibility for its fabrication and engineering in America. Schuco, after all, knows how to fabricate its products to its own quality standards, make them compliant with the US standards, and price them competitively.
All Schuco products are designed and engineered to achieve multiple levels of performance, not just thermal performance. There's acoustic performance, there's weather performance, and some of those things are inherent to other principles.
Schuco has been creating and inventing architectural aluminum glazing systems since the 1970s. For us here in the workshop in Newington, it was sort of a no-brainer to set up with the Schuco equipment so that we can easily translate our designs from the Schuco software to the finished product. The product we distribute is built under the optimal conditions and to the optimal quality.
Thank you, Schuco, for your sponsorship. And also, I would like to thank all of our sustainability sponsors. If you have any questions about sponsorship, feel free to reach out. And then I'm going to go ahead and get started today. Just a couple quick announcements, questions. If you do have questions throughout the webinar, please put them in the question box on your go-to panel, and we will answer them at the end of the webinar. We are recording this webinar today, so we'll make sure everyone gets a copy of that, hopefully by tomorrow. And you will also get a PDF version of the PowerPoint. So we'll go ahead and get started. I'd like to introduce Webley Bowles she is a senior project manager at New Buildings Institute. She's a licensed architect, and her expertise is in sustainable building and includes principle of design, construction, and operation. So Webley, I will hand it over to you.
Great, thank you. Go ahead and show my screen here. All right, we got the right one up, I think. Great. So,
yes, looks good.
Thanks. So as Jessica mentioned, I'm a senior project manager at New Buildings Institute. And some of my research lately has been around how to include embodied carbon requirements in building codes. And I'm also working on some research that is looking at how cultural institutions can preserve the artifacts within their buildings while reducing energy to limit the impacts of climate change to those artifacts. So that's to say that I am not a Windows expert in any way. You are. I did tour a Marvin Windows factory about 20 years ago, and I look forward to seeing how my skills and what I have to present today can help to inform your work as you kind of look at this industry and this topic. So a little bit about New Buildings Institute. We are a national nonprofit based in Portland, Oregon. We conduct research on high performance building technologies. We use that information to impact building codes and policies. And we work with great partners like NFRC to help inform those codes. And then we build market-facing deliverables that will help support designers and building operators alike to build a carbon neutral future that will protect people, planet, and profit as well, because the economy is also important. At MBI, we center our work on what we call the 5 foundations. These get us to a carbon neutral future. Each foundation has a scope, and it helps meet our climate solutions. The work I'll be presenting today is based on that last item, the life cycle impacts. It's often easy to skip over why decarbonizing the built environment is important. We've been carbonizing the built environments for centuries, and it's become the norm, but it's becoming easier to see the impacts of climate change. I'm in Portland, Oregon. It snowed 4 inches yesterday. It's April. That's not normal. The latest IPCC report says that it's now or never. It's no longer a matter of stopping climate change. We're working to avoid the worst effects and adapting to it. We also need action to make those necessary changes, and that has to happen today. But who wants to shift business practices when the cost of business is rising? When we are in the middle of a pandemic, when access to raw materials is becoming more difficult, transportation delays, and so on. I don't need to tell you what the problems are, but the best time to plant a tree is 10 years ago, and the next best time is now. And so we need to make change now, since climate change is not going to make our current operations easier. So getting to scale requires us to implement new initiatives quickly. And MBI is one way that we're doing this is through codes. And if you're a code wonk or policy wonk, you can read about MBI's code language for decarbonizing the code. We also have our latest reporting on using the International Building Code to address embodied carbon. You can see that on our website. So we also have a valuable database that I want to make sure people are aware of. This is our Getting to Zero Buildings database. It includes over 700 commercial Z&E projects, and about 90% of them, if not more, are carbon neutral. So they're all electric buildings. And that's a really great resource to see kind of what different technologies are being used in these important buildings. All right, let's get into embodied carbon. So if you're new to embodied carbon, then this will be all new to you. If you're not, you can kind of zone out for about 2 minutes. So operational carbon is pretty well understood by most energy advocates, but operational carbon is related to the energy used, operational carbon is related to the energy that's used by the building. So the electricity and the fossil fuels, and the embodied carbon emissions is the sum of all the emissions associated with materials from the extraction, the manufacturing, transportation, installation, and even the end of life of a material or a product. So when we compare operational emissions to embodied emissions, embodied carbon relates to the construction, and that occurs at different milestones. So you can see that here in that kind of yellowish orange color. So during building construction and at major renovations, you'll see those spikes, and that's where embodied carbon emissions occur. Operational carbon occurs kind of year over year as the building continues to consume energy. So operational carbon is flexible. It can be reduced through energy efficiency measures, whereas embodied carbon can't be. So it can really only be reduced at that time when you're purchasing those materials. So this chart shows 2 different building types in blue. That lighter blue is a code compliant building. These buildings often have higher operational carbon compared to higher efficient buildings. So that's what those 2 colors there are. So this chart has a lot of information on it, but it's really helpful. It uses the EU standard EN 15878, and it shows the carbon associated with all phases of a building's life cycle. So starting at the top, you can see the stages indicate the stage of life of a product. So these are product, construction, use, end of life, and beyond the life cycle. The module indicates the phase within the stage. This is why you need a chart for it. So for example, for a product, there are 3 different stages. Notice that the A module crosses 2 different stages. So you may hear someone refer to a product's embodied carbon that's measuring the cradle to gate emissions, and this defines the boundary condition. That's the same as saying the product stage or the A1 through A3. That's a lot of jargon, but hopefully this chart is something that you can go back and reference and kind of understand those different stages and phases. So below that boundary condition at the bottom, this is an estimated percentage of a building's total carbon emissions by stage. So this shows why embodied carbon is so important to address. We can see that in A1 through A3, we're looking at 50% of a building's carbon emissions, whole life carbon emissions, is associated with embodied carbon, while 43% is associated with operations. So as the building becomes more efficient, the use emissions will go down, and that embodied carbon portion will become a larger percentage of the whole life carbon for a project. So how do we know what the embodied carbon of a material is? We do that through looking at product life cycle assessments, or LCA. You'll hear me use that term, LCA, a lot. It offers the rigor and consistency that we really need to understand and trust the embodied carbon of a product. So a manufacturer may conduct a product LCA within by using an independently verified party in accordance with the ISO standards that you see there in that middle bar. And then once they have that LCA for that product, they hire a third party to review the information and create the Environmental Product Declaration, EPD. So that's another 3-letter acronym I'll be using a lot, is EPD. And I'll talk about that in more detail in just a minute. So then that verified EPD is registered through a program operator, and it's made publicly available. There's a lot more to say about EPDs and the rulemaking around them. I'll get into that just a little bit at the end to show you a couple of resources that if you're interested now. EC3, which is the Embodied Carbon and Conservation Calculator, has a really good guide on their website called How to Get an EPD, and that's a great resource to see how you can get an EPD. So there's 3 main types of EPDs. If you look at a list, you might see many more, but I'm just going to show you the main 3. So the industry-wide EPD represents typical manufacturing impacts for a range of products within a specific category. So you're not going to see, if it's an aluminum aluminum extraction, you're not going to see a steel extraction included in that industry-wide. It's just going to be for aluminum. And these EPDs provide the least specific data on a product's embodied carbon, but it does really help understand the typical impact for a product. So it's this very high level looking at a lot of different manufacturers. The product-specific EPD is the impacts for a specific product and manufacturer across multiple facilities, if they have multiple facilities. And the differences between the different manufacturing has to be lower than 10%. So there's less than a 10% variance there. And then facility-specific EPDs are product-specific EPDs in which the environmental impacts can be attributed to a single manufacturer and manufacturing facility. So from top to bottom, it goes to least specific to more specific. So the EPDs include information about the manufacturer, the product, the LCA methodology, the material content, emissions, waste, and so on. There's a lot of information about the product there, but it's really only data. The existence of an EPD does not mean that it meets a specific environmental standard. The EPD might disclose information about the product, like it might include environmental certifications like Green Guard or a specific amount of recycled content, but it does not claim that, it just kind of lists it. So this UK aluminum window EPD shows only part of an EPD. I just kind of snipped out this LCA results to show you. This, on the left-hand side here, you can see the 100-year GWP, global warming potential, and it estimates that global warming effects over a 100-year period time frame. There's a lot of other acronyms on here. So AP is acidification potential, EP is eutrophication potential, ODP is the ozone depleting potential, and so on. But GWP is really the metric that's used by most policies, the global warming potential, GWP, another 3-letter acronym I'll use a lot in this presentation. And on the right, you'll see what's contributing to those different emissions. So for this product, you'll see that the raw materials and manufacturing are the largest contributing factors to that total GWP, and that transportation is barely a blip. So why would we look at these materials kind of individually and not collectively? When we look at energy modeling, we're looking past the energy savings of a single window, and we're looking at the envelope or the system or the whole building. So we have baselines for energy modeling, and we can do the same for whole building embodied carbon modeling as well. So whole building LCA is a really important tool to evaluate the building design choices and comparing embodied carbon of multiple designs. So if you swap out one window type for another, you can kind of understand how those are performing in context. Whole building LCAs are also important for meeting third-party rating system requirements, like ILFI or LEED credit requirements. The main difference between looking at the EPD and a whole building LCA is that the LCA puts that material in context and states how much of the material is being used. When you're looking at an EPD and trying to compare steel against aluminum, steel is lower in CO2e by weight, but in context, you're looking at how much steel you're using compared to aluminum. So you really need that context to understand it. So we can look at the carbon in different stages, and that's what's great about the whole building LCA is that we can look at the upfront embodied carbon. We can also look at that whole life carbon all the way through the end of life. So let's look at how the industry is using EPDs and whole building LCA. So voluntary programs have considered embodied carbon for a pretty long time, and I really credit them for getting us to the point that we're at now. Half of the existing rating systems address embodied carbon. I think we're going to see that grow as embodied carbon is in more policies. So many architecture firms are documenting building embodied carbon, whether its clients are asking for it or not. Perkins & Will is a great example. They're making news by volunteering to design to net zero embodied carbon for all their products. There's a couple of voluntary reporting embodied carbon rating systems out there. HOK and many others are making commitments to SE 2050, which is the US Structural Engineers goal. AIA, the American Institute of Architects, has a 2030 challenge, which is committing to track and reduce and report embodied carbon. So there's a lot of these tools that are out there that designers are more interested in and becoming involved with. Carbon Leadership Forum has one of the best maps for finding the latest embodied carbon policies within their policy toolkit. Buy Clean California is probably by far the most popular policy that's been out there that people kind of understand. Colorado recently adopted their Buy Clean as well. In Washington, Minnesota are not too far on their heels. So the Buy Clean model requires that jurisdictional dollars that are spent on buildings and have products such as steel, insulation, glass meet specific low carbon requirements. So there's several other policies that you can see on the Carbon Leadership Forum website. The current administration signed an executive order late last year that essentially created a federal Buy Clean policy. The GSA, General Services Administration, is the largest landlord. They developed a policy to reduce embodied carbon in concrete and asphalt for all new facilities. And that's a pretty big deal because of the infrastructure deal that was passed. They are building a lot of new facilities, and they also have a lot of horizontal infrastructure or horizontal concrete and asphalt. So there's going to be a lot of dollars going towards that. At MBI, we have kind of a two-pronged approach for embodied carbon in the building code. This is at a very high level. Like I mentioned before, we have that document where it gets really wonky into the details if you want to see it. We have a materials level approach and a buildings level approach. And we're focusing on that buildings level approach on the left until the market really matures and that whole building LCA has the resources needed for regulation. Right now, I think it's fine for third-party rating systems. So we are focusing on two different aspects within that product level. First is that environmental product declaration reporting. So making sure that there are EPDs available. And the second is setting global warming potential limits, GWP limits for specific materials to meet embodied carbon requirements. Concrete and steel are some of the highest embodied carbon materials within products. And so we're seeing a lot of regulation kind of focused on those. Like how do we reduce those highest embodied carbon materials? So let's look at a couple of those different materials. I mentioned concrete and steel, and you can see here in this AIA chart that structure makes up about 50% of a building's embodied carbon. So once you understand that that metals use a lot of energy and bio-based products are generally lower in embodied carbon, you can start to consider what a lower carbon materials palette might look like. But those are generalizations, and it doesn't take into account how much you're using, the durability, and other important aspects of a product. So just because a product has a low embodied carbon footprint doesn't mean it's the best product to use. There's other goals. The other thing I wanted to mention about this chart specifically is that this looks at those upfront embodied carbon. So it looks at that A1 through A3 embodied carbon of materials. And it does not look at how the interiors might be replaced 4 times over that 60-year life cycle. So that 20% yellow pie wedge that you see there might actually be larger if we were looking at the whole life embodied carbon of a project. So I think I kind of gave this away a little bit. Concrete and steel are often the highest embodied carbon products on a project. So this chart comes from World Business Council for Sustainable Development, an ARIP case study that looked at different case studies in the UK. So they looked at commercial case studies specifically for this, and they looked at how the materials kind of broke down based on their embodied carbon. And concrete and structural steel are the most common intensive products here. That 20% services that you see kind of in the middle, that is related to mechanical, electrical, and plumbing. It's all kind of grouped together. And you can see there that glass is actually tied for 6th place with rebar. So RMI, if you're familiar with them, they developed an embodied carbon case studies as well. And they studied the cost impacts of selecting low carbon products. So for the most part, there was limited cost increase for selecting these products. So under the icon, that circular icon, there's a % reduction, and that's the embodied carbon reduction for that product category and the cost change for that category. So under glazing, you see a 3% embodied carbon reduction for glazing at a 10% cost premium, and that's only for glazing, not for the total project. So concrete offers one of the largest embodied carbon opportunities, and it's one of the easiest to reduce embodied carbon, but I'm not going to talk about it because we don't see it very often in fenestration products. So glazing is a critical challenge for reducing embodied carbon. Glass production uses a lot of energy and is often from natural gas, which is a high carbon fuel. Glass making also emits fine particulates from the vaporization and recrystallization of glazing. And the major emissions are the SOx and NOx, so the sulfur oxides and the nitrogen oxides. And those particulates contain heavy metals such as arsenic and lead. So that when we look at that EPD, it's important to look at that whole aspect of that EPD because there are other hazardous chemicals that can come from that manufacturing process as well. So unless we decide that we're going to go back to animal skins or animal intestines for our window products, I don't think that this is really going to change until we have some large scale manufacturing change. So RMI's study showed that the products available today can cut emissions by 25% for a 10% premium on the product. So these donut charts come from Anderson Window EPD, and it shows the embodied carbon of a material. It shows the embodied carbon of a material for each of the 3 different window types. So these look at the products and the 4 different materials used on them. So as expected, the glass dominates the product for embodied carbon, but we can also see that there's, depending on the frame and the hardware, so double hung windows have more frame and more hardware, and so that also changes the distribution of the embodied carbon for these Anderson windows. So steel is second only to concrete in global carbon emissions. The World Steel Association estimates that manufacturing of steel is responsible for somewhere between 7 to 9% of global CO2 emissions. So 2 tons of emissions is about the emissions a car emits driving 5,000 miles. And there's a little more than a half a ton of steel in the average car. So this kind of shows you how many miles of emissions is created from creating 1 ton of steel. But not all steel is created equal. So this is, you can see in this chart that there's a couple of different types of steel production here. And the amount of recycled content, the type of furnace that's being used, and the energy source really impact the final product's embodied carbon. Product designers have an opportunity to minimize the amount of steel in a product as well. So how can we create thinner mullions to use less product? Is that even an option? Does that work within design considerations? There's a lot of, as I mentioned before, it's not just what's going to reduce our embodied carbon. Zero carbon steel does exist. It's not available in the US at this point. It's often made with 100% green hydrogen, and it's difficult to find in Europe because car manufacturers have kind of secured it for their own supplies. Another thing to note about steel is that electric arc furnaces often have higher recycled, can often account for higher amount of recycled content within steel products, and they have a lower carbon footprint from the basic oxygen furnace that you can see there. And those furnaces use more virgin material and often have burned coal and coke. So wood. A lot of wood enthusiasts understand that timber products are the end-all be-all for sustainability. You know, they're more on the lower carbon side, but it's more complicated than just picking one single winning material and moving forward with it. The wood debate is really strong, and many claim that wood products can't be climate smart unless it comes from a climate friendly forest. So FSC is an example of that. So for every 1 kilogram of wood that's grown, almost 1.5 kilograms of CO2 is removed from the atmosphere. This means that the forest acts as a carbon sink, and how much of a carbon sink really depends on a lot of different factors. So you'll see that 1.47 to 1.8 kind of shift depending on 1, who you talk to, 2, where your data comes from, and 3, the different type of forest that it comes from. So sustainable forests are said to sequester more carbon because of the way that they're managed and that the way that the wood is harvested. There's a lot of debate on this. It's kind of in flux. We're waiting for more conversations to be had around wood for that to kind of shake out. But manufacturers can lower the embodied carbon of wood by using frames that come from sustainable harvested wood, and that the mill is closer to the project. That's also a benefit. So in our office, we sometimes joke that aluminum is congealed electricity because it's so carbon intensive. This image on the right shows the quality of the product produced in metric tons. So the yellow shows the embodied carbon per kilogram of material. And it's not really a fair comparison because aluminum is a lighter product and it's not used as much as, say, steel, but it's still very high in embodied carbon. It also has other benefits, that it's corrosive resistance, it's strong, so you don't need as much of the product. So again, it's not just a matter of comparing the products without any other context. You need that context. So since, or if I should say, aluminum is congealed electricity, the energy source really matters. So how can we reduce the energy source of all of this manufacturing to get it down? In New Zealand, aluminum is made from plants that are powered by hydropower, and so those have a much lower embodied carbon. But if we're looking at the whole life cycle, we also need to take into account how that steel, or how that aluminum is being transported and where the project is, to look at how the transportation emissions change over time and based on location. So PVC is derived from about 60% salt and 40% oil by weight. It's seen as a petroleum product, and it often only uses raw materials, so virgin materials. And PVC is rarely recycled, so nearly all vinyl windows contain virgin materials. But PVC can be recycled. I know in Europe they're doing much more around this, and I've seen more discussion around it in the US, and I'm hoping that we'll see this vinyl windows recycled content being much further away from zero in the future. But PVC uses less source energy to produce than other plastics. And the majority of all PVC is developed for construction, and it goes to PVC pipes, which I think is kind of surprising when you think that most of that is underground. WSP, which is a design firm, looked at a whole building LCA on the LaGuardia Airport, and they looked at different roofing materials, and they saw that the standing seam aluminum metal roof actually had a higher embodied carbon compared to PVC, and it allowed them to get a lot more LEED credits because of that. But it doesn't necessarily mean that PVC is better than aluminum. It was just in that context, it needed to be evaluated, and it was seen that that was a better choice for that project's goals. So I hope you've heard me say this a couple times, but there is no one product that's better than another, because embodied carbon is only one consideration. Other project considerations have to be taken into account, and it needs to be seen in context. So in a previous slide, I showed you how glass is often the most carbon intensive in a window product, and Anderson Donut showed that the frame type also mattered, right? So materials really matter when it comes to embodied carbon. And this chart shows that the embodied carbon of wood, PVC, and aluminum frames versus double and triple pane windows of the same window size. So we can throw in an operational carbon and make this way more complicated and consider how operational carbon and embodied carbon come together. This chart does not do that, but we need more research on that topic to be able to look at that whole life carbon. So it's important to remember that whole life, that these frames don't have equal lifespans, right? The end of life emissions for each of these is also different. So aluminum windows might have 40 to 50 year time frame, while PVC might be closer to 30. So again, we need to look at it in context and understand what the project goals are. So the opportunities for reducing embodied carbon really start in early design. So anything in early design, anything that you can include early design will be better because you don't have to do as much effort later on kind of adjusting things. So if we can kind of understand how we can reduce embodied carbon early in the design process, it will impact the embodied carbon and the whole building. So how can we understand the structure? Can we get that right so we don't have to redo it later on? Can we understand what that window to wall ratio is early on in the design concept so that that's kind of set in stone? So once we know that window to wall ratio, we can look at the materials that are being selected. Are they wood-clad casements? Are they inoperable aluminum frame windows? Once we get into specifying, the designer might select the number of window panes, so getting into more detail kind of as we go on, and understanding like what are the energy impacts of additional panes compared to the embodied carbon of additional panes of glass. So if clients haven't already asked for EPDs or any sort of product disclosures, they likely will. I have two final slides to show you to provide a little bit more guidance on EPD development. And as I mentioned before, I am an architect, I'm not in the manufacturing side. So this is not my expertise, but I wanted to give you a little bit of guidance as to where to look for EPD development. There's a couple of sources online. So this is from Underwriters Laboratory. And I mentioned that EC3 also has a good list and some links to follow. So one of the three-letter acronyms that I didn't really cover yet is the product rule category, also known as PCR. And that provides the calculation in the reporting requirements for creating an LCA, that life cycle assessment, which then goes into the EPDs. So these product rule categories define what that product is and how to move forward with the LCA. So this helps you know the standards that comply, the declared unit, the size that you're going to be looking at the embodied carbon on, and so on, and the units you'll use. So the first step is to identify the product category rule, and then to conduct that LCA, and then transfer that to the EPD format, the third party to verify the EPD, and then you register the EPD. But it all starts with that product category rule. So this image here is from the EC3 database. It is an EPD, Environmental Product Declaration database. This shows that the National Glass Association has an industry-wide EPD. And this also shows that there are 169 product EPDs for glazing, but only 17 of those are in the US. We have 47 that are in Europe and 70 that are from Asia, most of which are from India. So there's also 6 different extruded aluminum industry-wide EPDs for, and then there's also 38 product-specific EPDs for aluminum extrusions. So we hope to see this list grow, not only to comply with procurement policies that are coming up, but also to show what's possible in reducing embodied carbon in different fenestration products. What I think is so interesting about fenestration products is that they keep us visually connected to the environment. I sit in front of a window every single day, but it also keeps us thermally supported and comfortable, even with our rapid changing climate. With 4 inches of snow yesterday, I was still very comfortable sitting in front of a window. So These products are essential to enjoying our environments inside and out, and I hope to see that they become more environmentally friendly and meet different project goals. So just a couple of resources if you're interested in about 300 resources that are on MBI's website. We have this Getting to Zero Form resources hub, and we have a lot of different tools on there that may be of interest. Most of them are more design and policy based, but you might find something of interest as well. So I will throw my contact information up on the screen here. You can also tweet at MBI or find us on Instagram if you'd like. We're always happy to connect with people and find ways that we can work together.